Hello, everybody. This is Paul Ferreira again from Microbiology ASU. Want to talk about the fermentation and the cellular respiration process in Module 2 for the assignment. Glycolysis produces ATP and reduces the NAD and NADH while oxidizing glucose to pyruvic acid. In respiration, the pyruvic acid is converted to the first reactant in the Krebs cycle. Then the Krebs cycle produces ATP and reduces NAD while giving off CO2 through the ventilatory system through respiration, actual respiration of the body. If I understand it correctly, the NADH and the FADH from both processes carry electrons to the electron transport chain. And then in the electron transport chain, the energy of the electron is used to produce a high amount of ATP, the energy molecule, and with the addition of oxygen and water, has the ability to create energy molecules for the body to consume and convert to CO2 as a waste product. In the fermentation cycle, the pyruvic acid and the electrons carried by the NADH form glycolysis and are incorporated into fermentation products, as opposed to the whole addition of turning to ATP and the addition of water, kind of like yeast and bread. The goal of the cellular respiration is to convert the chemicals provided by food intake of the body to chemical energy that can be stored in ATP molecules to be used later when needed. ATP can then release the energy from the cellular metabolic processes required. Active transport and protein synthesis and muscle contractions are examples of those products of metabolic processes. All organic molecules can be broken down and stored and then used as a source of energy to produce ATP at some point in time. The process that occurs in respiration is the two pyruvate molecules enter the mitochondrion and are completely broken down, which in turn turns into 2 ATP and 10 highly energized electron carriers, along with 8 NADH and 2 FADH. I could say NADH, the words, but I can't pronounce them. So the carbon atoms from the pyruvates are then released into 6 molecules of CO2 and blown out during ventilation from the body during actual respiration. As a respiratory therapist, that's what I do. We actually are pretty familiar with the Krebs cycle and the oxygenation of the cellular respirations of the Krebs cycle, because we in turn always look at the ventilator, and depending on their energy release, the CO2 release, we can go ahead and make adjustments to the ventilator to increase or decrease the pH, the CO2, or the bicarb for that matter in the body, to maintain homeostasis or to bring the person back to homeostasis at the cellular level. During fermentation and the absence of O2 to complete cellular respiration, the fermentation process releases energy from food molecules by producing NAD to regenerate glycolysis, which takes place in the cytoplasm of the cell itself. Now, as far as I couldn't really find a lot of information about how much energy was produced by cellular respiration, but I did find that it reaches approximately 36 to 38 molecules of ATP per molecule of glucose, while fermentation doesn't. So as far as fermentation, I couldn't really find very much about that, the energy released per molecule. But that's about all I have. I hope it's sufficient, and thank you very much.